Welcome back to the channel, everyone. Today we're diving into the fascinating world of quantum computing. In this video, we'll explore the inner workings of quantum computers, how they differ from classical computers, and what sort of mind-boggling applications they hold for the future of computing. Quantum computers are built on the fundamental principles of quantum mechanics, in contrast to classical computing, where data is represented as bits that can only be in one of two states, 0 or 1, quantum computers use qubits that can be both 0 and 1 simultaneously. This is known as superposition, which enables quantum computers to perform complex calculations that classical computers would take an unfeasible amount of time to complete. Additionally, quantum computers leverage the principle of entanglement, which links qubits so that measuring one qubit instantaneously affects the other, no matter how far apart they are. This interdependence means that the potential computational power of quantum computers is enormous, and many experts believe it could revolutionize certain fields such as cryptography and drug discovery. Quantum computers process information using quantum gates, which are mathematical operations that can perform specific actions on qubits. These actions include flipping them, rotating them, or entangling them with other qubits. By utilizing these gates, quantum computers have the unique ability to compute exponentially faster than classical computers. One of the key ways quantum computers perform calculations is by using a quantum algorithm called Shor's algorithm, which can factor very large numbers exponentially faster than any classical algorithm. The implications for cryptography and data security are enormous, as current encryption methods are at risk of being broken by quantum computers. However, the development of post-quantum cryptography aims to mitigate this danger by creating encryption methods that are resistant to quantum attacks. The use of quantum computers and algorithms is a rapidly evolving field with immense potential for solving complex problems and revolutionizing industries such as finance, logistics, and pharmaceuticals. One of the most promising applications of quantum computers is their ability to simulate chemical reactions. Simulating chemical reactions on classical computers is an incredibly complex process that requires a lot of computational power. However, quantum computers could potentially compute these reactions much faster, which could significantly speed up the process of developing new drugs and materials. Another area where quantum computers could revolutionize the field is machine learning. Training neural networks on classical computers can take days, weeks, or even months, but with quantum computers, this process could be done in a matter of hours or even minutes. This could lead to faster development times for AI applications and ultimately lead to the development of more advanced AI systems. Despite being in their early stages of development, it is clear that quantum computers have an enormous potential for changing the way we approach complex problems in various fields. Quantum computers have promised a lot in terms of revolutionizing computing. However, the challenges and limitations in building practical quantum computers are many. One of the biggest hurdles that quantum computers face is the issue of quantum error correction. Qubits, the fundamental unit of quantum computing, are highly susceptible to noise and interference. Therefore, quantum computers must constantly correct for errors in their calculations. Additionally, building large-scale quantum computers requires scaling up to thousands or even millions of qubits, a feat that is incredibly difficult to achieve with our current technology. Therefore, despite their promise, quantum computers still need a lot of work to become practical for everyday use. All right, ladies and gentlemen, thank you for watching. I hope you found this video informative and interesting. If you have any questions, please leave them in the comments below, and be sure to subscribe to my channel for more videos on technology and science. I'm always looking for ways to improve my videos, so if you have any feedback, please let me know. Thanks again for watching.